Hello, welcome back. So, in the previous session, we have gone through all the three different methodologies involved in lexical processing. That is about understanding the word frequencies and what are all the stop words. And we also undergone tokenization and why tokenization is very much important and what are the types of tokenizers available in the NLTK library. And we have also understood what stemming and lemmatization and the trade-off between lemmatization and stemming based on the task which are currently doing. So in this session, what we will do, we will have a small hands-on session or a Python session, coding session, to understand these libraries, that is word tokenizers or sentence tokenizers available in the NLTK library, and we actually look into the action, like look in action for all these things. So let's just jump on to that right now. Yeah. So I have taken Jupyter Notebook, which is readily available open source by Colab, and that is Google's Colab. So you can actually log into the Colab website using your Gmail account, and we can actually directly jump into the Python coding activities using this Jupyter Notebook. And I will be using this as a code hands-on session for further sessions as well. So now let's just jump into uh, the theoretical part which we have discussed about the tokenizers. So we will just look into the action, like look how these tokenizers actually work. So for the very first step, we will just import this import NLTK, so as a library. So within that, we will be importing word tokenizer, sentence tokenizer, and tweet tokenizer. So these were the three tokenizers we discussed in the theory as well. And we have also discussed about one more sophisticated or advanced type of tokenizer, that is regex tokenizer, and I will be discussing later in this part. So I will first imported all these things. Now what I am trying to do, I am trying to tokenize the sentence into words. So that is, I am trying to use the word tokenizer, which is available in this nltk.tokenize. So I am using this word tokenizer and trying to generate word tokens for a given sentence. So I went to the Wikipedia. So I am taking a one first a sentence here, like Tendulkar took up cricket at the age of 11. So I'm taking this sentence as an example. So I'm inputting that as a example for this word tokenizer. So I'm passing this sentence. So according to our theoretical explanation, what we generally expect by this word tokenizer would be, we will try to split this sentence into individual tokens or individual words, right? So let's just see and like what exactly the results we are getting. So I'm going to store this word tokenize or words generated or the tokens generated in this variable called words, and I'm trying to print that words. You can here you could clearly see that the word tokenizer could able to split the sentence into individual tokens, right? So the Tendulkar took up the cricket at the age of 11. Now it is into individual words. It will be in the form of list. So it's a list of strings saying Tendulkar took up cricket at age etc. As a individual tokens. So that's what the word tokenizer actually do. Now we will look into the other type of tokenizer, that is sentence tokenizer, right? So what theoretically we understood about sentence tokenizer is that it will basically split the paragraph or a set of sentences into individual sentence. Like it is a master of word tokenizer, right? So it is a one step above over the word tokenizer. So word tokenizer generally splits the sentence into words, but sentence tokenizer will split the paragraph or set of sentences into individual sentences. So for that, what I have done, so I have like gone to the same Wikipedia page. So Tendulkar took up the cricket at the age of etc. And so I am taken until this uh, sentence. So I am taking this entire part of paragraph as an input to the sentence tokenizer, and I am expecting to split this entire paragraph into respective sentences. So let's just have a look on that. uh, okay, so I have taken Tendulkar took up the edge of the, and all the thing etc, and I have passed that entire paragraph into this sentence tokenizer right now. So what I am expecting here is, I want the set of sentences into individual sentences. Like I want the entire paragraph to be splitted into individual sentences. So how we basically decide it as a sentence? So we will decide it as a sentence when the sentence is ending with the full stop, right? So that's where the sentence ends. So here you could see the first sentence is ending at here, so 24 years. So the here where the full stop comes. So this is one sentence, and the another sentence begins from this line, so that is in 2002 halfway until VV recharge. So we expect output as two different sentences instead of a entire paragraph. So let's just run this again once again. So and we will see. So what is the output? Yeah. So it is again a list. It is a list of two different sentences here. Yeah, we will actually examine it. Yeah, here you could see. So it has successfully splitted the first part of a sentence into one element and another sentence into another element. Like now the paragraph is available with a list of two different sentences. So that's what the sentence tokenizer will do. So on top of this, I have also explained. We will not directly feed this set of sentences into the any NLP task or NLP algorithm. So what we will do, will further apply the word tokenizer on top of this sentence tokenizer, right? So what I am trying to do now is, like I have taken the sentences, that is the sentences two different, that is list of two different sentences which are generated. So I am taking that sentence, I am iterating over that. So I am using a for loop. It is basically a list comprehension. So I am taking a for loop. I am passing like I am taking each and every sentence from this list, and I am passing that sentence uh, from the list of sentences to the word tokenizer again. So that's what I am trying to do in this step. So I am taking each and every sentence from the list of sentences, and I am passing each sentence to the word tokenizer. So what I am trying to expect here over here is, so I will get a list of words again or list of tokens again, but with a slight modification. So I will be getting the list of words associated with the first sentence in a one list, and set of tokens or the words associated with the second sentence in a separate list. So I will get a two different set of list of words. So that's what we are trying to do over here. So let's have a run on this, and I will try to print out that as well. Yeah, so here you could see it is a list of list, right? So it is a list of list. So the first list will be the first sentences, the first sentence will be split into individual words again. So here you could actually see yeah, so here you could see that it has splitted successfully each sentences into respective tokens. So the first sentence is split and stored in one set of list, and another sentence will be splitted into words and stored in another list. So this is what we try to do when we actually build an algorithm or a text analytic problem, when we try to build a solution on NLP. So now further we use these words in order to build any type of NLP task. Say it is a sentiment analysis, text classification, topic modeling, anything. We generally process these steps as a mandatory when we move into the NLP analytics. So we will also have a look at the third part or a third type of tokenizer, that is tweet tokenizer, right? So as I mentioned, it is a sophisticated or a same basic algorithm of word tokenizer, but it is capable of handling additional features. So it is capable of handling a Twitter data or tweet, right? So now what I am trying to do, I have also imported that tweet tokenizer from the NLTK.tokenize. But one thing you can here notice is that these word tokenizer and sentence tokenizers are basically the methods that are available in the NLTK.tokenize. But this tweet tokenizer is basically a class. Okay, so it is a class which is available under NLTK.tokenize. So if it is a class, what we have to do, we can directly apply the method directly in this format. So what we can do over here is, like, we have to create a variable and we have to instantiate the class. So we have to instantiate the class in this way. So I'm creating an object of this class, that is TWT tokenizer, and then I am trying to call this method tokenize from this model or object which I have created. So now I have created this object already. Now I have taken this object and I am trying to call this method tokenize. So I am trying to pass a Twitter tweet. So you can notice it is a classic example. So in this Twitter data here, you could see never ask a girl who is a hashtag Twitter addict why she is late, and a emoji over here. So a smiling emoji or a laughing emoji at the end of the thing. So now our Twitter tokenizer should be able to split this tweet into individual words or individual tokens so intelligently that, so it shouldn't split that never ask a girl who is a hashtag separately and a Twitter separately. I wanted this hashtag Twitter to be individual token, and also this emoji, that is laughing emoji at the end, as a single token, not the splitted part of this. So let's see whether it's working fine or not over here. So yeah, here you could see it could able to split that hashtag Twitter into a single tweet or a single token over here, right? So it has considered it as a single token, has a hashtag Twitter Twitter, and here this emoji also able to classify as a single token. So I will actually show you the difference. What if we use the same word tokenizer to split this entire Twitter tweet? So let's have a look on this as well. So I'll take this copy of this. Uh, okay, so I will try to add that. So instead of this Tendulkar statement, I will try to pass this tweet now. Okay, until here. Yeah, so I have passed this entire tweet. So I'm trying to make you understand what are the key difference between this sophisticated or intelligent tweet tokenizer, and what are the capabilities of tweet tokenizer, and how it actually handles the data differently. So I will run this now. Okay, now I will print that list of words which it has generated. Yeah, so this is the key difference. That's what that was I was trying to make it out or point it out at that point. So this tweet tokenizer could able to split this or consider this as a single token, right? See here, you could see it has considered hashtag Twitter as a single token, but this the more less sophisticated or a generic word tokenizer couldn't able to differentiate that as a hashtag Twitter, right? So it has generated hashtag as a separate token and Twitter has a separate token, and even this emoji is not handled by that as well. See here, you could see that the colon, it has considered it as a colon and a bracket, right? So it has splitted that into single colon and a separate bracket. But what we actually wanted, we wanted to split this as a single token, right? This emoji should be considered as a single token. That's what we could able to achieve over tweet tokenizer, but not it with a classic word tokenizer. So this is the major advantage of this Twitter tokenizer or tweet tokenizer available in the NLTK library. So by this session, we could also have a understanding of how exactly these tokenizers work, and how the action, and how each tokenizer is different from each other, and unanimously why these tokenizers actually come into picture when we deal with the text classification or a text analytics.